All right, so let's take a look here at question number 28 from our homework week 7. So it says to solve the problem, write and then solve a proportion. Refer to the illustration below. A St. Bernard website lists the ideal proportions for the height at the withers to body length as 5 to 6. So what is the ideal height at the withers for a St. Bernard whose body length is 27.5 inches? Okay, so guys, anytime you're presented with a word problem, always figure out what it is that you are being asked for. And it usually is going to start with a word such as what or something like that, and usually is going to be in the sentence that is a question. All right, so here's the question. And in particular, at the very beginning, it says, what is the ideal height at the withers? So that's what we're trying to find. We are trying to find an ideal height at the withers. All right, so we are going to be setting up a proportion. So remember, a proportion is when you set two fractions equal to one another, and each of those fractions is going to be comparing two things. So notice here at the very beginning it says that we have some St. Bernard website that lists the ideal proportions for height at the withers to body length. All right, so basically both of our fractions are going to compare those two quantities. It's going to compare the height at the withers to the body length. All right, and I always suggest that you kind of write something like this out at the very beginning. All right, so our proportion is going to compare two of these. So height at the withers to body length. All right, so this website tells us what that ideal proportion is. It says the height at withers to body length is 5 to 6. So height at withers to body length is 5 to 6. So height at withers, 5, to body length, 6. So this right here, this is the ideal proportion. So now we should be given one of these two, which will allow us to then solve for the other. All right, so then in our little question portion here, it says, what is the ideal height at the withers? So that right there tells us that we are going to be solving for the height at the withers, and we should be given the other piece of information, and you'll see that we are. It says for a St. Bernard whose body length is 27.5 inches. All right, so what is the ideal height at the withers for a St. Bernard who has a body length of 27.5 inches? So we've got 27.5. So here is our proportion that we need to set up, right? So basically this is kind of step one of the problem because it says to solve, write, and then solve a proportion. So we've now written our proportion here. Now we just have to solve it for this unknown value, which is height at the withers. Let's first off rewrite this mixed number just as a fraction. So we're going to have 5 all over 6 is equal to our variable HW, which stands for height at the withers, all divided by. So we're going to take this mixed number and turn it into a fraction. So remember, you take 2 times the whole number. So in this case, our denominator of 2 times the whole number of 27. So that is going to give us 54. Oh, excuse me, I don't know why I was writing that. We still have one more part to do there. So you take 2 times 27, which is 54, and then you have to add the numerator to it. So 54 plus 1 is 55. I could have kept that 5 there anyhow. And remember then, whatever denominator you're working with is still the same denominator that we have here. So 27.5 is the same thing as 55 over 2. So now, to solve an equation where you have two fractions set equal to one another, you need to cross multiply. So that will be our next step. So starting here, we have 6 times the height at the withers. So this is going to be 6 HW is equal to, and then on our other diagonal, we have 5 times 55 over 2. So I'm going to write this as 5 over 1, that's just the same thing as 5, times 55 over 2. Okay, very good. So now we need to multiply these two fractions together. So remember, when you're multiplying fractions, you're just multiplying straight across, numerator times numerator, denominator times denominator. And let's see what we get. So in our numerator, 5 times 55, excuse me, so what are we going to get there? Let's get out our calculator so that no mistakes are made. 5 times 55 is 275. All over, and our denominator here is 1 times 2. That's just going to be 2. And over there on the left-hand side, we still have 6 times our variable, which we're calling HW, for height at the withers. All right, so we still need to solve or isolate HW. So the reason that HW is not currently by itself is that it's connected to this 6 through multiplication. So we undo that multiplication with division. We'll have to do the same thing to the other side, right? Whatever you do to one side, you have to do to the other. So this multiplication by 6 cancels out with this division by 6. And now we have that our variable, height at the withers, is equal to, and we have 275 all over 2. I'm going to write this out. We'll all see why in a second. 275 all over 2. And now this is divided by 6. So think about this as a fraction. Think about 6 as a fraction. That's 6 over 1. So dividing by 6 over 1 is the same as multiplying by 1 over 6. All right, so we end up then with the height at the withers is equal to, and just like we did up here, guys, to multiply these two fractions, we'll have to do the same thing down here. Multiply numerator times numerator. 275 times 1 is just itself, 275. All over 2 times 6 is 12. All right, so let's see if we get a nice answer when we divide that out. 275 divided by 12. So divide this by 12, and that is equal to, we do not get a nice answer, 22.9. And it appears that my internet browser quit on me. So this is our answer, guys, 22.9. Hopefully that is good enough. If you happen to have a further question on this problem, please do send me a message and I can show you how to get this value in a fraction.